The the hydrofoil design could be designed for various different functions and options. A foil design for high speed would look different to a foil design for load carrying, or for a ferry boat. It's all to do with the ratios and the thickness of the foil. If you think about in the case of aeroplanes, a big load-carrying aeroplane would have massive, long, big wings. A fighter aeroplane would have sweep-back, small wings. It's very similar to hydrofoils on a boat, and that's the beauty of it. When you want to design a boat for a specific need, in some cases the hydrofoils will be a main hydrofoil that spans the tunnel. The stern foils are normally two smaller foils, but in the case of load carrying, it could be one through foil. The reason for this stern foils being smaller, a hydrofoil get to a certain point where it actually could create a resistance, and it can make the boat go slower. So the main foil is normally situated at the lowest part of the tunnel. The water would lift it to the surface. The stern foils, slightly higher up in the tunnel, would assist with the lifting of the boat out the water. Once it gets onto the main foil, the stern foils will actually lift out the water and start running just above the surface of the water, because it's not needed anymore. The boat's out on the water, and the resistance on the main foil is reduced quite a lot. If you run a load carrying boat and you have a dual foil system, as it's called, the main foil could be a foil that runs from the one side of the hull to the other side as well. And often the stern foil could be adjustable, so when you run with heavy loads and the load is not distributed very well, you have the option of actually balancing and trimming the boat with a rear foil. In the case of smaller craft, especially outboard driven boats, you have trim and tilt function on your outboard engines. This trim and tilt function effectively is not only trimming the engine at the back of the boat, it is also setting the hydrofoil angle, which is quite important for the performance to be good. So that's the function. On some of the new diesel engines with surface drives, they have a trimmable system that would do exactly the same thing. The bigger the boat, the less sensitive it would be for trim. But there is options of doing load carrying foils, high speed foils. We've got some products doing more than 70 knots. So there is also a certain speed where the hydrofoil would become dysfunctional. Like on an aeroplane, at a certain speed or a certain turn, the flow can break off the wing and the aeroplane can fall out the sky. Similar to a boat, at certain speeds the flow can start breaking off the foil. It would then stop all lifting forces and it would actually start cavitating, and the boat will actually go slower. But we found that this limit is quite high, above 70 knots. There is some special foil designs for higher speeds, which looks totally different to the conventional foils, but that's for racing and for serious military sort of application.